So let's start. In the beginning, some words about our company. The company Helmholz was founded 37 years ago. And you see here a picture of our headquarter in Großen Seebach near Erlangen in southern Germany. Mr. Helmholtz started with PLC programming, so the roots of the company are coming out of the PLC programming and doing machinery stuff. But we started very soon to invent our own products, in the beginning for Simatic S5, later for Simatic S7, and nowadays for industrial communication. Yeah, near Erlangen in Bavaria. We have over 90 employees and 75 of them are on site here in Großen Seebach. We do almost everything in-house, so we have the development of the product, so software and hardware development. We have the marketing, the sales, purchasing, and also the production of the products is done in-house. The only part we do not buy ourselves is PCB assembly. So we have partners here in the near vicinity which are specialized on PCB assembly. They have the special PCB assembly lines, but we do the mounting and final testing and configuration of the products after we got the assembled PCBs. We have over 36 years of experience in automation and more than 50 million products sold since 2000, I think, because our sales software does not go further back than the year 2000. We have more than 1,500 customers worldwide. And this is an overview over our main part of our product range. So from the left to the right, from the more simple products to the more complex products. And we start with the products here on the left side, which are network connectors for Ethernet, 100 megabit or gigabit, or especially for the use case of Profinet. And the next level, it's the monitoring. So we have products for monitoring or analyzing frames of Ethernet cables, also for cabinets. And the next pillar is unmanaged switches in different sizes, different versions. And the next is managed switches for Profinet, especially for Profinet. We have an own I/O system for connecting sensors to the network. TB20 I/O system for sensors and actors and analyzing data. Here on the next pillar, we have the gateways for connecting different or similar machines from one to the next. So Profinet to Profinet, Profinet to Profibus, or connect CAN bus devices to the machine. And on the highest level, we have the routers for remote maintenance. And we will talk today the Wall IE, the firewalls. Okay, so let's dig into the security topic. Why is security in the industry so important now? I think you already know because you already have experience in discussing security, but I will give you a short background. The main topic is that we have Ethernet everywhere, so machine is not an island anymore. In the past, we had Profibus or Modbus RTU or other serial communication lines to connect the devices to the PLC. But since many, many years, I think 10, 15 years, the machines are getting more and more connected by Ethernet, and even the internal communication is over Ethernet. So Ethernet is the standard we are using in communication or for data in the machine. And the communication in the beginning, it was only a connection to the PLC to get some data or to do the programming. And later on, we used Ethernet for everything, for the sensors, for the I/O systems. Everything is connected by Ethernet. And on the other side, from the sensors, it's cloud. So we connect to the high-level systems, to the MES systems, the enterprise data stuff, and even up to the cloud. So the connection even to the internet. And this is what is expected by the customer, and the machines are getting more complex. Yeah, increasing digital complexity. So all the different needs of the customer, of the machine, of the factory, of the data acquisition, of the data management. The result of all this is we have communication everywhere in our machine. And also on the other side, we have this data protection law going on. So if we handle some personal data or stuff like this, we have all the legal parts of data protection. So we were already forced to do something in the company and possibly also inside the machine to protect personal data. Yeah, and all this Ethernet everywhere, communication everywhere, and complexity in the communication, the connection to the cloud brings up new people to our OT world. In the past, the IT guys already have experience with these special guys, these hackers. But now in our OT world, we also get some experience with the hacker guys. And yeah, what do they do? There are three different types of hackers. The first ones are the criminal attackers. They spread ransomware, and your IT and also possibly your OT will stop working because it's scripted, and somebody wants to have possibly money, Bitcoin stuff to regain your machine data or machine programs. The next level are industrial attackers. They are more focusing on industrial information gathering. And the highest level, I think we also can talk about this, are political attackers, so sabotage or even information gathering, but on the level of political other countries attacking, going into machines with software to get information or possibly to do sabotage. Yeah, and you think your machine is already protected, so it's what you see. You see a beautiful castle with everything, and it's protected. But on behalf of the hacker, he knows where to go. He knows what to do to infiltrate your machine because he is an expert. And if we are handling with political attackers, with high-level attackers, they will possibly find a way in your machine, in your factory. And all this situation leads to some legal requirements, which lately came up from the European Union, but also in other countries. But the European Union is in the moment, let's say, in front of all these legal developments in the world. And this is what I want to show you today and explain today. So what do we have? Security, especially on security, we have regulations, directives, and normatives. And there are some topics we should, as a machine builder. And the first thing we have, and we will talk today, is the machinery regulation, the new one. This machinery regulation in the past and today is normally focused on product safety, but in extension of all this discussion we had on the slide before, this machinery regulation was updated, and the big part of security was included in this new machinery regulation. And this machinery regulation is effective and has to be active and implemented by January 2027. So we should start today to do something with our machines. The second important part is the Cyber Resilience Act. And the Cyber Resilience Act is also a regulation. And this is focused for products. So this is not focused on machines, but it's focused on products like our products we are providing. And for example, also for the firewall Wall.IE I'm today also talking about. And the Cyber Resilience Act enforces all companies which are producing or importing products to the European Union and which will be used in the European Union, possibly inside machines, that they also consider strong recommendations of security in their products. So this is for us as company Helmholtz. We have to develop our products according to the Cyber Resilience Act. And this will be effective in December 2027. So it's the same, it's in 2027. Both of these regulations will be effective. So we have the both sides, product manufacturers and machine manufacturers. And these are regulations. So these, if you read them, and I put a link here for the machinery regulation to the European web page, you can read the machinery regulation. And this is, let's say, it's a law, but this regulation does not include information about how to do it, how to get a machine or a product secure. And for this, you need harmonized standards, harmonized normatives. And one of these will be the IEC 62443, which is a normative which is already existing since many years and is widely used step by step by the companies today. And this is focused on industrial products, industrial communication, and industrial control systems, PLCs, and everything around all the products and all the setup you have in your machine or in your factory. And I will explain this also later. And then one more regulation or one more directive in this case is the NIS2 directive. And we also have to consider this because this NIS2, also from the European Union, this one is focused on the IT, on the company IT. So your IT as a company, your router, your server, everything you use to be a company, from your office IT to your PCs you are using to program your PLCs and everything you use. This also has to be, let's say, raised the bar for security in your IT. And this is especially focused on critical infrastructure companies, so like an nuclear power plant or an hospital, or let's say all this infrastructure energy companies. But the extension of the NIS2 is that also companies providing services or products for these critical infrastructure companies, they also are falling now under this NIS2 directive. So even we as a company Helmholtz, with our routers we are providing, are falling under this NIS2 directive. So we also have to implement this in our IT. Okay, so let's take a closer look to the machinery regulation, to the new one, and especially the focus on security we will have today. So the first thing, it's changed. The old machinery directive, or the old regulation, was a directive. So now it's a regulation. In the past, it was a directive, and regulation means it applies without national laws. You have to implement it until January 2027. And this applies to machinery, total machine, partly completed machinery, and associated products, which is a big range of, let's say, machinery parts you can add to your machine or you deliver for other machines. So everything which is not a simple product. But there are some exceptions, safety components, the yellow boxes, a little bit out of scope because they are already regulated in other regulations which are effective already. So it's a part of the machinery regulation, but there are other laws already effective. And also exceptions are cars, trains, airplanes, ships, military, nuclear facilities. So there are many types of machines are not in this machinery regulation. So machinery regulation focuses on machines you can implement in a factory for production or for process industry or stuff like this. The main focus of the machinery directive in the past and the machinery regulation today is the safety function of the machine. So, and this is everything you do to protect people from the machine. So the machine does not harm people or also affects assets or affects, for example, also nature. So if you have a machine and it is handling some chemicals, and you have to maintain to secure that these chemicals are not going in the river, and so the river, the nature is somehow affected. But the main focus is protecting people from the machine. This is what you did in the past. If you plan a machine, for example, with a robot, and you have an area where nobody can enter, because if he's coming near the robot and the robot is moving around, he can possibly injure or kill people. So this is a typical view of the machinery directive in the past and machinery regulation. But the new focus we are today handle in the new machine regulation is the other side, the other view of this problem. Security, protecting against risk from digital technologies and communication. So we connect our machine to some communication, and we get risk from this side. And this is meaning protecting the machine from people. So protecting the machine from the hacker or from people which are not know what they do from in the communication. So this is a different view of this protecting. Security considerations of a machine. So what are the security? Yeah, what do you have to consider if you take a look on your machine? You're already building machines and delivering machines, but what is the new considerations you have to do regarding security? And the first is you have to do a security risk assessment. You already do risk assessment on the safety part. Yeah, what risks do arise from having a robot which is moving around? What is the safety risk of this robot? And now you are taking a different approach, and you're now looking on the security risk assessment. So what can happen if this robot is connected to the internet or to the high level network? What can happen here? What is possible risk from this view? And you also have to consider the selection of components according to security requirements. In the past, you did a selection of the components regarding safety considerations. So if you know you need a robot, you need some safety components to secure this robot. And now you should start to consider components like a switch, like the PLC, like everything for communication, like gateways, also firewalls. And these products, you should take in consideration the security view of this product, not just buy a product. Ask the manufacturer, how is the manufacturer handling the security part? And you can ask them if they have implemented this product on behalf of the normative 62443, for example. I will explain this later. What does it mean for everybody? Or latest end of the 2027, each product manufacturer has to adapt to the Cyber Resilience Act for their products. And really important point, and we will talk about this also today because it's a big topic, it's the network design. So we talked in the beginning about the risk having all connected. So you have this Ethernet connected, the PLC, the drives, the panels, HMI panels, everything is connected with the mid-level or high-level network of the factory. It's possibly connected to the internet. And if you have this, or if you have needs from the customer is demanding this connection, you have to take in consideration your network design. So there's no everything is connected to everything, but it's more a zones and conduits topic. Also really important, this is more a topic for not even the machine builder, but also the factory owner, the asset owner. is all the access rules. So who is allowed to change something? How do the people authenticate against a PLC, against a PC, against an HMI, and so on. Yeah, protection against corruption. And this is a big part which is emphasized in the machinery regulation, is if you have a running machine and everything is okay and working and you tested it, how do you protect your machine against any changes? For example, changes in the PLC or changes in the parameters. And what do you do against this corruption? And also, if you have a running system, a running control system, you also have to take in consideration the reliability of the system. So reliability means, okay, your machine is running, but if somebody is affecting, for example, there's a switch inside the system and somebody is attacking this switch and the switch is failing, for example, does the rest of the system maintain working, or is it going in a safe state, like in the safety part? So you also have to take in consideration problems in communication or attacks on the communication lines, and the reliability or the safety of the control system has to remain. You need a vulnerability management and a patch management. So if you have a safety focused machine and you test it and you get your stamp from, let's say, TÜV, and they say, okay, your machine is safe on the safety, on behalf of the safety. And if you do not change anything on the system, you know that this will be safe today, but it will also be safe tomorrow and 1 year and 2 years, because you do not change it, nothing changes. On behalf of security, this is different, because if you have an actual PLC, for example, with an actual firmware inside, and this is secure today because nobody knows any vulnerabilities, but tomorrow there can be it can be that some hackers find vulnerabilities inside this PLC nobody knows before. So you have to monitor if there are some new findings on behalf of security. And if there are findings and you say, okay, I have to update my PLC because there is some security vulnerability showing up, you have to have a patch management in your machine or at the end customer, at the asset owner. And this is needed. And all this talking about never change a running system, this is not true anymore in the future, because a system could be okay today, but tomorrow it could be a security risk. Also really important is all this logging stuff. So to see if a machine is somehow attacked, you will not see the result at the moment. If somebody is attacking a PC, the first thing the hacker are doing is implementing some backdoors. And you will not see anything, any changes for your machine or any changes for your PC. You cannot be sure if at this actual moment, your actual PC you are sitting in front of is not already affected by some hacker. You don't know it, because these hackers are not using their backdoors in the moment they establish them. They use it later. They use it for ransomware if they affected all devices in your machine or all devices in your IT, and then they start their, let's say, attacking or ransomware and stuff like this. So you need some logging to see if something is going on in your machine. If there are, let's say, normally you have a login in your HMI only in the morning if you start your machine, and in the logging you see in the night some people try to log in your HMI system, and you say, okay, nobody was in the factory, what's going on? You need this logging, you need the analyzing of the logging. And also really important for the security are your operating instructions. Your operating instructions you have to write for your machine on behalf of safety will have new chapters on behalf of security. And this security description is really important, because you are building a machine, but you have this asset owner, the factory owner, which is using the machine, and he needs information about the security in your machine and how to use it and how to get, for example, the access rules and the authentication. What is possible? What security functions he can use? Also really important here is design documentation. So if you plan your machine, if you design your machine, your network, your functionalities, you have to have a good documentation for your CE certification and everything, and also the changes of your PLC program, of your web page setup for the HMI or whatsoever has to be documented. And last but not least, training for your personnel, training for everybody. Your human resources has to start finding training for all the security considerations of the machine. Okay, so let's go into two paragraphs, two things which are directly out of the new machinery regulation, which are directly, let's say, imprinted in the machinery regulation. And this is the protection against corruption. And the second part is safety and reliability of control systems. So protection against corruptions, connection to other systems, or remote access. And this is remote maintenance, remote access. We also provide these products for this purpose, must not lead to a dangerous situations. So you have to design your machine in a way that if you connect the machine to a high level network, or you connect remote access solutions, a router, to your machine, that your machine cannot be, let's say, dangerously affected. And this is the conjunction between security and safety. So the security is the part where you think about communication, attackers over communications lines, and your end product has to be safety. So if somebody is attacking your system over an Ethernet line, your machine has to be safe. So no explosion, no dangerous movement of the robot, and so on. So this is a connection between security and safety you have to consider. And so all security relevant software, data, and hardware components that transmit signals or data must be named and protected against corruption. So the easiest way, the easy example you have, if you have a connection of your PLC to a high level network or to remote access, the typical way to secure or make your PLC safe is to have an extra authentication or password level before you can change software in your PLC. So this is a practical example how to use it. So all PLCs should have password protection, and this should be effective if you deliver the machine to the end customer. So this is really one example, one good example how to solve it, and this is demanded by the machinery regulation. It's one way to do it, a different way is possible, but this is a typical way. And also changes must be documented. I already mentioned this. So second part is the paragraph 121 in Annex 3, safety and reliability of control systems. Control system must withstand the reasonable, foreseeable, malicious attempts by third parties to create hazardous situations. So this is overlapping a little bit. The first paragraph is nobody can change something in the machine, and the second part is more focused on somebody is attacking like a denial of service attack on your network or whatsoever. So the safety and reliability of your system has to be maintained. Nevertheless, somebody is attacking your network, attacking devices in your network. For example, communication failure, a total loss of communication in your machine should lead to a safe situation, a safe state of your machine. Or it's not possible to have unexpected startup of your machine. So somebody is friggling around and your machine is doing some unexpected resets. And for example, the robot is moving in his base position. Or also validate parameter changes. If somebody is inside your machine and starts to, let's say, change parameters, for example, the maximum speed of the robot arm, and you have to validate it to reasonable values. For example, the typical speed is between 1 and 10, and some hacker is typing in 1000. And if you do not validate it, possibly the robot will explode or whatsoever. Yeah, and now you come to the point, okay, I have my machine, I have to do some security considerations of my machine, but how do I know how much security I have to implement? How deep do I have to go in the security considerations, in the risk assessment? And this is a point you cannot do on your own desk as a machine builder. You have to talk with your customer because it's depending on the use case. So for one point is the use case. So if you have machines to do packaging, you know the use case is the packaging machine is in a factory and there are people possibly around the machine. So you have the safety part. And the typical case is inside a factory. But you also can have machines like controlling for cranes or building machines or stuff which are outside somewhere else in the world, not in the factory. And you have the different use cases of your machine. And the use case is also changing if you have different customers or different factories where your machine is installed. And also a big topic is that you have, for example, one customer, and this customer is demanding to get all the data from your machine. I want to have an OPC UA, MQTT, remote maintenance, everything. I want to connect to this machine as an end customer, and my service technicians are somewhere in the world, and they have to connect to this machine. So okay, this is a really big security risk. And you can have another customer said, okay, put the machine in my factory. I don't need any Ethernet communication. It's enough for me to have an HMI panel in front of the cabinet, and my guys are going to the cabinet and push the buttons, and everything is okay. I do not need any complex communication with your machine in my factory. So you can say, this is a low-level risk assessment. So depends on the use cases of your machine. But the most important point is that the safety functions and the security functions must be clearly defined and documented. So you have to have, let's say, a list of requirements and functions which is you can deliver, or on the other side, the customer is demanding. So connections like OPC-UA, MQTT, web interface, remote maintenance, and you list all of them and say, okay, these communication ports has to be handled in the risk assessment. Yeah, and how to do it in the practical way as a machine builder. And then we take the normative IEC 62443 and the -3, I will explain it on the next slides, is a part which is focusing on the machine builder. So, and you can read this normative, and this has all the practical approaches on security for your machine. And there are also some more new harmonized standards like the EN 50742, which is focused on remote maintenance, and some more. For example, if you have some wireless products inside, you have to take in consideration the radio equipment directive, which also has a new normative about how to handle wireless devices on behalf of security inside your machine. So there are some more, but the main focus you can handle is the 62443-3. And you do all this stuff, requirement, risk assessment, patch management, or everything. And at the end, you have to make conformity assessment and a CE declaration. I will not go deeper in which possibilities you have. Can you do it by yourself, or do you need an external like the TÜV to do it? It depends on your machine, depends on the security and safety levels of your machine. But at the end, you have to declare the part of security inside the CE declaration. yeah, as I said, valid from January 2027. Okay, so let's go deeper into the 62443, or let's explain the 62443 normatives. You see here, it's at the moment it's divided in 4 parts. On the left, you have general with terminology, concept, and models, glossary, and some general parts. And then you have the part 2, 3, and 4. And these are focused on the different people which are handling products, machines, and factories. So we begin on the on the left side, the -4, and this is the normative part you have to read to understand and to establish in your company for product manufacturers, like the company Helmholz. And at the moment, we are implementing the 4.1, the secure product development lifecycle, and implementing this in our company. So we will have this year a TÜV certification for 62443-4-1 for our product lifecycle management. So how to develop secure product, how to handle secure product, how to do the risk assessment of the product, the vulnerability management of the product, and so on. And regarding the features, the requirement inside the product, you have the -4-2. So this is a list of features, recommendations you have to implement into the products to get them secure. The next -3 I already mentioned in the slides before is for the machine builder, for the solution provider. So for you as a solution provider, machine builder, and this incorporates all the topics I already talked about on the machinery regulation. So machinery regulation says you have to do some things, and these things are explained how to do in this 62443-3. So you can read it, you can implement it, you can do your risk assessment regarding on this. And if you scope with all the topics inside this -3, it's possible that even assessment center, even a TÜV would say, okay, if you did all this, your machine is possibly secure. And on the -2 part, this is for the end customer, the operator, the asset owner, the people who are responsible for the factory, which have inside machines, different machines, and producing stuff, or process manufacturers, and they have to do the high level stuff, like who is allowed to access to the machine, who is allowed to access to the cabinets, how do I maintain the patch management, vulnerability management, what do I have to do on my IT level to protect the OT level, and so on. Okay, and one big topic in the machinery regulation, and which is more especially explained in the 62443, is the network design. So how to do the communication, how to manage the communication inside a factory from your machine to the high level. And in the past, the classic approach, which is normally implemented by the IT guys of the end customer, so the administrator, the IT guys coming from here, from the enterprise network. And the boss of the factory said, okay, we have to implement some machines inside our factory. We have to connect them to our network in our factory. And the IT guys getting a little bit busy and said, okay, we have to do something. And their approach normally is they use managed switches, using virtual LAN and stuff like this. They have solutions. But coming from the other side, from the machinery regulation, from the IEC 62443, we are talking about conduits and zones. And conduit is to restrict communication between trusted zones. And the trusted zones are already here in this picture. You see the high-level enterprise network with, let's say, IT, office staff, web server, and you have an enterprise firewall to connect with the internet. Then you have enterprise DMZ, demilitarized zone, which is more inside the factory, but for inventory management, all this MES systems, and then you have the machines, many machines inside your factory, and these are different zones of trust. And for example, the easiest view on this is the company owner, the asset owner, the factory owner is not trusting you as a machine builder, and you as a machine builder should not trust the IT of the factory, because on both sides there could be some vulnerabilities, some risks on behalf of security. So, and to solve this on a more physical level, on a more plannable level, the normative 62443 are talking about conduits. And conduits are devices, possibly most devices, which are connecting different zones. So, for example, a firewall. And router is also a possibility to use as a conduit, or even gateways, like if you want to connect two machines with different protocols like Profinet, and on the other side you have Ethernet IP. You can go on the high level network to communicate between the PLCs, but you can also use gateways between the machines, and these gateways are also conduits between different zones of trusts. And one example, a product we have, it's Wall.IE. We have this product since 8 years, 9 years, 10 years, I'm not sure, because we saw this topic coming, security, all this Ethernet connection between different machines, between the machine and the factory network. We know you will need something to handle this. And this product has different functionality to scope with the needs on behalf of security, but also on the practical approach, how to connect a machine to a high-level network. And the first thing, the typical use case you have is that you have a company network of your end customer. You have your machine, but your machine is already planned and designed with other IP addresses like the company network. And in the past, you had to change all IP addresses. You had to reconfigure your machine to somehow adapt to the IP addresses of the end customer. But our point was to say, okay, take a small product like the Wally, put it in between, and then you can decide which IP addresses can communicate with which IP addresses in the company network. So you have this mapping table. You take some IP addresses from the end customer, and then you map them to your devices. So this is the NAT, the network address translation. And this is the first level of security, because you decide which devices can be connected to the high-level network. And this leads to the use case. For example, this is a more complex machine, and you see not only the PLC and the HMI, you see all the devices you have in your network. And you can now control which PC has the is allowed to access to, for example, your PLC. And in this example, the SCADA device with the IP address 10.10.110 is allowed to access to the PLC, but only to the PLC, because the SCADA system only needs data from the PLC. Sorry. So you have a whitelist with NAT, so the address translation, but also a whitelist which says this PC is allowed to access to this PLC. So this leads to the point that if you have somewhere in the company network an attacker, let's say on this office PC here on the right side, and he wants to access to your OT system, and this is not allowed because this office PC is not allowed to access any of your devices because it's not in the list. So if somebody in the office or somebody on the, let's say, factory floor level has a PC for some special things, and he is not allowed to access to your machine, you have the security level here. And this is also going in both directions. You can also configure not even who is allowed to access from the company network level to the machinery network level. It's also possible to say only special devices in my machine are allowed to connect to the company network or even to the cloud if it's needed. So if you have a PLC and this PLC has to send data actively to some PCs in the network, this is allowed if you allow it, if you add it in the list. But if you have, for example, a device, an intelligent device, and this also wants to connect or to connect to the internet or to do something, this is not allowed. So you have also this point, only the devices in a whitelist are allowed to connect to the high level network. So both directions. So, and at the end, if you have, for example, already adapted your machine to the IP network of the company network. So, for example, this machine is already existing and it's already adapted from the IP addresses to the company network. You can also take the volley in between this communication line and just use the bridge mode. It's called bridge mode. It's a bridge, but you also have all these functionalities. You have the functionality filter IP addresses, so who is allowed to talk to whom. You can also address only the communication on ports. For example, you can only access a PLC only the web page, but you're not allowed to access the port for changing the PLC. And protocols, MAC addresses, so you have all these filter functionalities. So this is a Wall IE for different purposes. This is a short video how to configure it. It's really simple. You have a web page and you can set up a list of filters and you can configure the NAT and the network part. So it's not so complicated. So go to the next. So Wall IE is a product family. You see here in the picture, we have three different. In the middle is a classic version. And we have a smaller version here on the right side. It's a compact, which is able to communicate gigabit, has a faster processor. And on the left side, you have the Wally Plus, which is also able to communicate on gigabit. And you also have a switch installed. So you have an 8-port switch, and you can use 1 port for the high level network and 7 ports for the LAN, or you can mix it. Yeah, the features, low-level effort to secure integration of machines into high-level networks. You can also integrate many similar or even equal machines with the same IP addresses. If you have 10 machines which are all the same and you want to get them inside the factory and connected, you can give each machine different IP addresses. The Wally also improves network performance by filtering broadcast and multicast. So not all Ethernet frames or traffic which is in the factory network will be copied inside your machine. And this is also improving your network performance and network reliability inside your machine because you only get communication you want to have. Yeah, quick and easy configuration. Security by design, for sure. This is the approach we also see in the 62443 normative for us. You have to scope with security by design. So you think the development of the product from the security point of view. It's very small. Okay, let's come to the end of my webinar. At the end, I would like to tell you a little bit more about, or a short topic about where to go from this point. What is the first thing you should do as a machine builder regarding security? And the first thing you should do is get information. So you have already machines, you have products, you have a PLC, you have devices, switches, and you have to talk with the manufacturers about these products, about security of these products. Where do I get information about security? Yeah, so security in a general way, like today in this webinar, but there are many more possibilities. Where do I get firmware updates? Yeah, you know of some manufacturers. They have a web page, and somewhere on this web page in download area, there should be a new firmware if there is a new firmware. But you need to somehow handle the information channel? So do you get the information about the update? Does this company communicate with you if there is a firmware update and this firmware update is security related? So open the communication channels. How can I secure my device configuration? Is also a big topic. How do you know what is your configuration of the device, and how do you see if the device configuration was changed by somebody? And if it's changed, can you recover to the original configuration? So do you have all the configuration saved in the secure area and so on? And yeah, who can I ask about possible security issues? So who is the guy, the people on in my factory, or even on the machine builder side, or on the product manufacturer side? Who are the people I can talk to and exchange my needs, exchange my requests or requirements for security? And a typical connection point, and which should be available in all companies scoping with security, is a product security incidents response team. And this third team we have at Helmholtz already since a couple of years. And this team knows everything about security, about the security of the existing products, about how to handle vulnerabilities, vulnerability management, how to get information about security. And this is a team you can talk with at your manufacturer, or you also should implement in your company somehow to have people responsible for security, and they can handle requests or new information or security incidents coming from somewhere. You can contact us by email or by phone, and we have a special web page called CIRT. You can read about how we are working. And we need a big partner on this, because we cannot do it by ourselves. And our communication partner and exchange partner on behalf of security is ZVDE. VDE is a community of German electrical engineers, and they have a computer emergency response team, a couple of people which are working on this. And on this community set at VDE, there are also all the other companies here in Germany, like Phoenix, Vago, Beckhoff, and the bigger ones, and also the smaller ones are, I think at the moment, 70, 80, 100 companies are actively exchanging information, communicating, discussing, and also we use this channel to communicate our security, let's say, advisories or stuff like this. So this is a central channel for communication. And other partners we have is here in Germany, Teletrust is the IT security community, a big one. And for sure, we have this Bundesamt or Federal Office for Information Security here in Germany, which is also a big information source and communication source for OT security lately. And especially with the Cyber Resilience Act coming up here in Germany, the BSI is responsible for getting the Cyber Resilience Act into the German companies. Okay, so that's for today, a little bit longer than planned. It's a big topic. Let's get secure. That is the point. We as company Helmholtz are already deeply inside, getting our development life cycle secure, getting our product secure. And we already have this security topic in mind since 10, 15 years, because we have the routers for remote maintenance, we have the firewalls, we have the gateways, we have the switches. So we already did penetration tests and all the stuff for our products. But on the situation today, we have the law, the Cyber Resilience Act, machinery regulation, and stuff like this. And we also have the normative part, the 62443. And this both together makes it better handleable. It's a big block and on work, but you have something. You have to read it, you have to implement it, you have to do it, and then you are high-level security, because this is what you have to do. And on the machinery regulation, it's the same. You have to read it, You have to implement the scope, the stuff of the 62443, and then you can easily get your CE certification or CE declaration for your machine, and you can handle security in the future. There is no perfect situation. You cannot be 100% secure, but this is not the topic. The main topic is what you do, not the result in I have tested something, I have some certificate. This is important, for example, but your process, your process in getting the product secure and keeping them secure. This is the important part. Okay, if you have any questions to this topic, just contact me, contact my colleagues by phone, by email, whatever, by Teams, and I'm always open to discuss it with you. And yeah, we can help you on some topics. We are not able to do the work for you, but we can help you. We can discuss it. So thank you very much, and have a nice day. Here in Großen Seebach, you see the sun behind me. It's a beautiful day. And I hope to see you, to hear from you, and I hope this information is useful for you. Thank you very much. Goodbye.